Okay, welcome to JC Connect. In the previous class, we were discussing about the how effective is the UV radiation. Okay, the effectiveness of the UV radiation is depends on the characteristics of the UV distribution system that we already discussed, and we discussed. It depends on the system hydraulics also. It depends on the presence of particles and it depends on the characteristics of microorganisms. So when I say it is the characteristics of microorganisms, for example, even if you consider the virus itself, there are many kinds of viruses are there. Sometimes the uridation is may effective for some other viruses. It may not affect for some other or other viruses. Okay, depends on the type of mechanism involved in the microbes. Okay, the chemical characteristics of water as well as the wastewater. So exactly this dose, whatever the UV dose can be defined. So the effectiveness of this UV disinfection is based on the UV due to which the microorganisms are exposed. Okay, the UV dose is defined as follows. Okay, so D is equal to I into T. So D it is UV dose in millijoules per centimeter square, and I is the UV intensity. Okay, this one is milliwatts per centimeter square. Okay, then how much time it is going to expose. Okay, so this will the I, eh, we can call this as dose in terms of energy millijoules per centimeter square. Okay, then intensity, if you measure the intensity of this UV dose, it will be measured in terms of power. Okay, then how much time you are exposing that microbe. For example, you have microbe is there, so the UV ray is going to hit. So how much time it is going to hit? So even if you hit for only 1 second, so it is not going to kill. Okay, then even if it is exposed for 20 to 30 minutes or at least more than 10 minutes, so you can say the killing of the pathogens is going to happen. It depends on the exposure time also. Okay. Then whatever the dose you are applying, okay, it is equivalent to the UV intensity and the exposure time. This W stands for the watt. Then advantages, as no chemicals are used in this process, no taste or color is added in water during this process. Remember this. Okay. Um, it is a natural process. Um, Even if it is there in natural color, then only the UV disinfection is an effective. Suppose if you increase the what we did already the previous discussions, if any turbid water is there, if you added any color to the water, so then it is very difficult to apply the UV disinfection process. Then disadvantage is this process is very costly. Why? Because we are using the mercury based lamps. So we are using mercury based lamps. That is why it is very costly and requires technical skill and costly equipments. So that is one more thing, and the technical manpower is required. That too, they should be very efficient to handle the UV-based radiations. Therefore, it is not used at the waterworks. Okay. Still, in some of the major applications, this has been prepared and the compacted water treatment units or in your houses, if you are using any of the treatment units, then you always, if you see the Kent is there. Kent is a brand. There you can see that water filter. Normally, the Kent water filter, if you observe, there UV disinfection they will mention. Okay. The sense inside the UV rays are going to generate and it is circulated through and the water. So once it is circulated through an water environment, so if any pathogens if they are present in the water, that is going to kill. Then uses, so disinfection with disinfection with ultraviolet rays is mainly done for treating the small quantities of water in hospitals and dispensaries for the surgical uses, okay, or for drinking purpose at places where the cost is minor factor. So this is very important. Whenever if you are recommending any of this UV treatment, so always keep it in mind that if you're not worrying about the cost of the treatment, then directly go for the UV disinfection. And the main thing is that if you go for UV disinfection, normally till the life of the bulb or the life of that generating material, if it is for a long time, till then you will get the UV radiations. Okay, so maintenance is very less compared to the other disinfection process. The maintenance is very less. So it is also used for the disinfection of swimming pools in water, because if disinfection is done by the chemicals, they may cause harmful effects to the skin of the people taking bath. Always in swimming pools also they will use it, but care should be taken uh, for the exposure of the human beings to that UV radiations. That is why most of the time we'll use the uh, iodine. Sometimes we'll use it. Okay, so UV of course very less. It is preferred in most of the swimming pools, but still some of the sophisticated swimming pools where the barrier has been created for the UV disinfection. So then this can be used uh, in some of the applications. The disinfection by gamma radiation. So gamma rays are emitted from the radioactive sources such as the cobalt 60 and are effectively used for disinfection of water. Okay, from the cobalt 60, um, this is the one element. It is going to emit the gamma radiations. Okay, even it is used for the disinfection of water, wastewater, as well as the sludge also. These rays have high penetration power comparing with the previous what we were talking about, the UV radiations. It is having high penetration power. See, in the previous UV radiations, you can say it is 30 centimeter to 60 centimeters. So the depth of penetration, but it is higher than 60 centimeters. The method is reliable and does not leave any residual chemicals in the effluent. So this is the best advantage of the UV radiation as well as gamma radiations. No residuals are absorbed. In the sludge, the gamma rays alter the makeup of the sludge, benefit dewaterability and stability. So this will not discuss. Only we'll discuss about the water treatment facility itself. So overall, you can say that even the gamma radiation is used for the treatment of the water to kill the pathogens. Then disinfection by bromine. So bromine is a heavy, dark reddish brown liquid. The addition of bromine to water forms hypobromous acid, so HOBr. Okay, it is nothing but HOBr. The dissociation of the acid resulting in the formation of the hypobromite ion. Okay, the formation of hypobromite ion. It's very simple. Once you add this bromine, so water plus bromine, so it will form HOBr. Okay. Then later it will dissociate to OBr minus. So this ion we can call it as hypobromite ion. Also, this bromine reacts with ammonia in water to form monobromine and dibromine. Okay. No stable tribromine is formed. Okay, only two, that is mono and di, which is a strong bactericide. See, whatever this formation, what we are talking about, see this ion, hypobromine ion, and later when ammonia is present, remember, so now it is forming OBr ion. Remember, if it is forming OBr ion, so this is also a good disinfectant. That is one case. In the second case, suppose if bromine, if it is going to react with the nitrate, okay, so then it will form mono bromo anion. Okay, mono bromo anion it is going to form, as well as dibromo anion. Okay, so these two, whatever the mono and di, okay, they are all strong bactericide. Bactericide in the sense it is going to kill the pathogenic bacteria. The bactericide means it is going to kill the um, bacteria that are present in the water. So bromine has been used for disinfection of swimming pools of water on limited scale. Remember this. However, because of its higher cost and less effectiveness, its use for public water supply has not found acceptance. So normally it is not feasible as the cost is compared, but still it is used in some of the sophisticated swimming pools. Here also you won't get any residuals after the treatment process. Then disinfection by iodine. You can take any ointment or if any wound is happened to your body. So normally most of the ointments consist of this iodine, bromine. Okay, iodine it contains, sometimes bromine also. So these two acts as and disinfectants. Remember, in the sense, what will happen is that if any wound happens, there is chances of infection by the most of the pathogens or the microbes. If you protect from the all these microbes or the pathogens which are going to attack on the wound, so then the iodine will be mixed or the bromine will be mixed with the lime. So that is a good ointment. So if iodine, if it is going to mix with CaO, okay, or CaOH twice, so perfectly it is a good ointment. Okay. So then iodine is a bluish black solid, and its addition to water yields to hypoiodous acid. Okay, it forms hypoiodous acid, that is HOI, and it will form hypoiodite ion. Okay, initially it will form this, then later it will form the hypoiodite ion. See, these two ions acts like like disinfectants. Acts like a disinfectants. So iodine reacts less with organic matter compared with the chlorine and is relatively stable in water. Both iodine and hypoiodous acids are equally good disinfectants. So iodine does not react with the ammonia to form iodoamines, but oxidizes ammonia. See, just like in the previous case, what the di and mono um, amine it is formed. No? So here it is not going to form, but it is going to oxidize ammonia. That is the sure. So it also oxidizes the phenol. Because of these reasons, less iodine is required to obtain the free iodine residuals. Okay, here also even you can keep the free iodine content even after treatment process to to prevent the further contamination in the distribution network. So iodine has been used for disinfection of swimming pools of water and small quantity of water in the field. So iodine tablets have been used by the army. Okay. See, if they are, this is very important thing. See, in army sectors, what will happen is that sometimes they have to use the water wherever they stay there. Okay, sometimes it is not possible to provide the proper treatment facility at the point of where the army people will stay. In that cases, this iodine tablets will be used whenever if they want to disinfect the water. So that time they can use these tablets and they are going to kill the pathogen. Then they will use it. Okay. Sometimes 1 week, 2 weeks they will be there in the camp. That time it is not possible to provide Kent like water filters at that point of time because no boats will be there. Okay, it is highly difficult. In that cases you can provide, or you can, if they bring this iodine tablets, so they will dissolve it and they will wait for example, if 10 liters of water is there, 10 liters, so what they will do is that they will put one tablet and they will mix this and they will keep it for 20 minutes, so then they will drink that water. Okay, so iodine is and the very important thing is that this whatever the iodine dose, it has to be optimized before adding to this, because what will happen is that even if you add more iodine tablets to this uh, water, most of the time even it is going to kill the stomach bacteria also. So once the some stomach bacteria are going to kill, so then normally the health upset is going to start. So iodine is also dependent on pH, temperature, time of contact, and nitrogenous impurities than the chlorine. So comparing with the chlorine we'll discuss later. Okay, as for now, we can understand that it is less dependent on pH, other parameters. Okay, that is why it is used in the military base camps and all those things. Okay, there the proper pH check of the water quality parameters is not required. But when you are using the chlorine for in your water treatment process, so it is must to analyze the pH, temperature, time of contact, and nitrogenous impurities. It also going to kill the amoebic cysts. So if amebia is there, so that is going to kill. So almost all the pathogens which are present in water is going to kill. Because of certain advantages over the chlorine, iodine is better for post disinfection process than the chlorine, providing longer lasting protection against the pathogens and reducing uh, affinous taste and odors. However, it is more costly than chlorine. The very important thing is that um, slight smell will be there, slight taste is going to change, but uh, that much taste you cannot judge that some taste has been changed. But if you observe crucially, so then definitely a small change in the taste it is going to observe. Even the small light color it is going to change, but still if you optimize the iodine, how much I have to added for the killing of all these pathogens. So then directly it can be recommended. But only thing is that it is more costly than chlorine. So iodine and bromine, how much dose has to be added? Remember this. Okay, the dose of zero point 0.8 ppm is required. So zero point 0.8 milligram per liter you can add. So contact time of 5 minutes. So then you can some of the small contact basins are available like tablets. So that tablets can be used in the disinfection process. So then disinfection by ozone, as we already know that the ozone, it is nothing but oxygen plus the nascent oxygen which is going to give the O3. But it has to be created in the laboratory. It has to be created in the laboratory with the ozone generator. With the help of the ozone generator. So this is also a good disinfectant. So ozone gas is faintly blue gas, pungent odor, and is an excellent disinfectant. Ozone gas is an unstable allotropic form of oxygen, which is the molecule containing three oxygen atoms. So it can be produced by passing the high tension electric current through a stream of air in a closed chamber under the following chemical reactions. See, this is going to create with the normal oxygen only, but it has to be created in high tension electric current. Remember, okay, it is created in high tension electric current. So ozone generators are available. So there you are going to create this. So the three times of oxygen molecule it is there under high collecting arc voltage. So it is going to create O3. Because of its instability, ozone readily breaks down into normal oxygen and releases nascent oxygen as follows. See, if you are storing any of the O3, okay, it has to be stored in the leak-proof cylinders. Leak-proof cylinders. Suppose if you don't use this leak-proof cylinders, if if it's going to come out, so immediately it is unstable in nature. Okay, it is unstable in nature. Immediately it will form O3 is going to dissociate into O2 plus nascent oxygen. Okay, so then again the reverse process. So this is fine. No energy is required here. See conversion of from O3 to O2 plus O. Okay, no energy is required. But in reverse case, if you are converting from O2 to O3, okay, it requires a lot of energy. That which is going to happen under electric current that we already discussed. The nascent oxygen soap produced is a powerful oxidizing agent and removes the organic matter as well as the bacteria from the water. So whatever the nascent oxygen, it is also an the um, most powerful oxidizing agent. Okay, even it is going to remove the organic matter up to some extent. So about 2 to 3 ppm of ozone is generally consumed so as to obtain the residual ozone of 0.1 ppm after the contact period of 10 minutes. So then how much time you have to keep it? So dose will be, remember, dose will be 2 to 3 ppm. Okay. Then residual ozone is zero point 0.1 ppm. Okay. Then you have to keep the contact period of 10 minutes. That you have to remember. Okay. The dose will be 2 to 3 ppm. Contact time is 10 minutes. And the residual disinfectant what we are talking about. Previously I have explained the concept of residual disinfectant. Why residual disinfectant is required after the treatment process to stop the further contamination in the pipelines. Okay, here also, even after this ozone, we have to keep some residual ozone of 0.1 ppm to stop the further contamination in the pipelines. So ozone is unstable, produces nascent oxygen, and it is also a powerful oxidizing agent. So 2 to 3 ppm produces a residual of 0.1 ppm after 10 to 15 minutes. Also removes color, odor, and taste. It needs skilled labor. This is very important. It requires skilled labor. So this ozone chemistry, of course, is not required as the your syllabus is concerned. We'll skip it. If you want, you can read it later. Then ozone, the effectiveness of ozone is the ozone is extremely reactive oxidant that we already know, and bacteria kill through an ozonation which directly because of the cell wall disintegration. They already said that how UV is going to act on the cell wall of the bacteria. The same way it is going to kill the pathogens. So directly it will attack on the cell wall of the any of the pathogens. One the cell wall, for example, this is the bacteria. This is the wall. What will happen is that it is going to break this wall first. If you apply this ozone, so it is going to break the walls of the um, pathogens. Ozone is also very effective viricide and more effective than chlorine. Okay, it is going to kill the viruses, then more effective than chlorine, but it is more costly. Ozonation does not produce dissolved solids and it's not affected by ammonium ion or the pH effluent to the process. So ozone disinfection is prepared over the chlorination or hypochlorination where the dechlorination may be required and high purity of oxygen facilities are available at the treatment plant. This we'll discuss later. As now, ozone disinfection is why it is preferred means that it is not going to produce any of the dissolved solids. Okay, so you can call it as after whatever the 0.1 ppm residual will be there. Even it will go after some time, nothing will be there. Okay, just like the chlorination process, it won't produces any of the chlorine byproducts of ozone byproducts. See, it is completely clear disinfection process. The advantage is that the dissolved oxygen concentration of the effluent will be elevated near saturation level so as the ozone rapidly decomposes the oxygen after the application. If anywhere the DOE is going to or DOE is very less in some of the cases, um, even if you add this ozone, it is going to increase the oxygen level in water. Okay, the increase in oxygen concentration uh, may be eliminated for the need of re-aeration of the effluent. Okay, ozone is being unstable. Nothing remains in water by the time it reaches the distribution system. As I said, even 0.1 ppm, if you keep it for 1 day, it is going to disinfect and nothing will be there. Okay, ozone removes the color, taste, odor, bacteria from the water. Other than the pathogens, of course, it is a very disinfectant. Other than this, it is going to remove color, taste, as well as the odor. The ozonized water becomes tasty and pleasant, unlike the chlorinated water, which becomes bitter and tanned. Normally, the ozonated water it will be tasty because oxygen content is going to increase. But if you add more chlorine, okay, you will come to know that the chlorine is added. Okay, slightly it will be bitter and to a tongue. Okay, sometimes eye irritation will start. So that kind of symptoms you cannot observe in the ozonized water. So disadvantage is costlier. Okay, it requires electricity. Okay, uh, very important thing is that no residuals are maintained sufficiently. See, the residual chlorine, for example, residual bromine, if you maintain it, at least it will be there for 3 to 4 days in a distribution network. If the pollution has happened in between these 3 or 4 days, so it is going to kill. Or if bacteria are entered in between these 3 to 4 days, so it is going to kill. But um, this O3 only it will be there for about 1 to 2 hours in a pipelines. After that, it is going to dissociate as O2 and nascent oxygen. So then you cannot find any residuals. So that is also one major drawback. It is going to create the residuals, but it won't be there for the long time. Just imagine that it is a 2 hours is where and 3 to 4 days is where. Okay, that is why almost we can say it is no residuals is going to exist in the distribution network to stop the further contamination. Okay, then disinfection by the potassium permanganate. We'll have the discussion in the next class. Any doubts you can ask or will wind up?